Hello viewers, welcome to my YouTube channel. Let's make maths easy. In this video we will be discussing the previous year questions of the topic trigonometry. So let's start with the video. See the first question. It is prove that tan a plus secant a minus 1 upon tan a minus secant a plus 1 equals to 1 plus sin a upon cos a. So actually there are two ways of solving this question. One is we can convert this tan into sin upon cos, and this secant a can be written as 1 upon cos, and then we can take the LCM of numerator and denominator, which after rationalizing will give you this right hand side. There is one more way. I am starting with that. So left hand side is tan a plus secant a minus 1 upon tan a minus secant a plus 1. I am writing in numerator this 1 as secant square a minus tan square a, because secant square a minus tan square a is 1. Now I am applying the identity of a square minus b square over secant square a minus tan square a. So this will become tan a plus secant a minus a square minus b square will be a plus b into a minus b, and keeping the denominator as such. Now if we observe the numerator, we can take out this secant a plus tan a. It is here also, it is here also, so we can take it out common. So taking out secant a plus tan a common, we are left with 1 minus this whole secant a minus tan a, and denominator is same, tan a minus secant a plus 1. Now I am expanding this numerator, opening the brackets. It will be 1 minus secant a plus tan a upon tan a minus secant a plus 1. Now you observe this factor, this one, this is minus secant a and this is plus tan a. So this whole factor cancels with this. We are left with secant a plus tan a. Secant a can further be reduced to 1 upon cos a, and tan a can be written as sin a upon cos a. Now taking the LCM, it will be cos a is LCM, and this will be 1 plus sin a, and this was your RHS. You can see 1 plus sin a upon cos a. This is your RHS. So this question is proved. Let's move to the next question now. So in second question it is given sin alpha is 1 by root 2, cot beta is root 3. Find the value of cosecant alpha plus cosecant beta. So with the help of this sin alpha we can find cosecant alpha, because sin and cosecant are reciprocal of each other. So cosecant alpha will be root 2 upon 1, which is root 2. Now with the help of cot beta we can find out cosecant beta, because there is one identity which relates both cosecant beta and cot beta, which is cosecant square beta minus cot square beta equals to 1. So substitute the value of cot beta here. It's cot square beta, so root 3 square will be 3 now. So this gives cosecant square beta as 1 plus 3, which is 4. So what will be cosecant beta now? It will be under root 4, which is 2. Now we have cosecant alpha and cosecant beta. So we can easily find cosecant alpha plus cosecant beta, which is root 2 plus 2. Taking out root 2 common, it's root 2 plus 1, and this is your answer. Move to the next question now. It's question number 3 is, if sine theta plus cos theta equal to root 3, then find the value of sine theta into cos theta. So I am starting this question with the given, and I am doing squaring on both the sides. So on squaring both sides, it is sine theta plus cos theta whole square, and this is root 3 square. Now applying the identity over left side, which is a plus b whole square. So this is a square plus b square plus 2ab, and root 3 square is 3. This sine square plus sine square theta plus cos square theta is 1. So this is 1 plus 2 sine theta cos theta is 3. So 2 sine theta cos theta is 3 minus 1, which is 2, and 2 and 2 cancels, which is giving you sine theta cos theta as 1. This is the answer for your third question. I hope this question is clear to you. Let's move to the next question now. Question number 4 is, prove that under the root 1 plus sine a upon 1 minus sine a equals to secant a plus tan a. This question was in 2020 paper, and this is the question from your NCERT also. So let's start with the left hand side. What we can do on left side, we can rationalize it. So it will be 1 plus sine a upon 1 minus sine a. So on rationalizing, we will write 1 plus sine a upon 1 plus sine a. Now in numerator, we can see it's 1 plus sine a into 1 plus sine a, which can be written as 1 plus sine a whole square. And in denominator, it's an identity, a minus b, a plus b, which is a square minus b square. Now I am separating the root over numerator and denominator. So it will be under the root 1 plus sine a whole square upon under the root 1 minus sine square a. This root cancels with this square, leaving only 1 plus sine a in numerator, and in denominator 1 minus sine square a can be written as cos square a under the root. Now this root cancels with this square, giving you 1 plus sine a upon cos a. Now separate this cos a over numerator, which is cos a plus sine a upon cos a. So this is secant a plus tan a, which is your RHS. So this completes the proof of this question number 4. Moving to the question number 5, which is very important. And this particular type has been asked many times in previous year question. See the solution part now. It's given to you here that tan of a plus b is root 3 and tan of a minus b is 1 by root 3, and question is to find the values of a and b. So what we can do is, we can make equations in terms of a and b, which further can be simplified using elimination method, right? So this root 3 can be written as tan 60. Now this tan cancels with this tan, means a plus b is what? 60 degree. Same way, tan a minus b 1 by root 3 is the value of tan when it is 30 degree. So this gives a minus b as 30. You call this equation number 1 and call this equation number 2. You see it's plus b in equation 1 here, and it's minus b in equation number 2. So on adding both the equations, on adding what we will get? This a plus a will become 2a. This plus b will cancel with minus b, and this is equal to 60 plus 30, which is 90. So what is the answer for A? 90 divided by 2, 45 degrees. Now put this value of A as 45 either in equation 1 or in 2. I am putting in equation 1. So from equation 1, 45 plus B equals to 60. It means B is what? 60 minus 45. B is 15 degree. So A is 45 and B is 15. Let's move to the next question now. Question number 6. It came in 2019 paper. So you see the left hand side. We will start with left hand side and prove right hand side as 2. So this is 1 plus sine square theta, this is 1 plus cos square theta. Secant square theta, we can convert this into cos, and cosecant square theta can be converted into sine square, right? So we will start with this thing. So left hand side is 1 upon 1 plus sine. No change I am doing in first two terms. In last two I will do the change. I am writing the secant square theta as 1 upon cos square theta, because secant and cos are reciprocal of each other. Same way I am writing cosecant square theta as 1 upon sine square theta. Now I will be simplifying the third and fourth term. See, we can take the LCM of the denominator, which will be cos square theta. I am shifting that LCM to the numerator, so it will be cos square theta upon cos square theta plus 1. Same way denominator में भी sin square theta LCM है, which we can shift to the numerator, so it is this term. Now I am taking LCM of all the four terms. So you can see here it is 1 plus sin square theta, here 1 plus sin square theta, this is 1 plus cos square theta, 1 plus cos square theta. So LCM can be 1 plus sin square theta into 1 plus cos square theta. This one will be multiplied with 1 plus cos square theta. यहाँ 1 plus cos square theta already है, so we will multiply it with 1 plus sin square theta. This cos square theta will be multiplied with 1 plus sin square theta. And you just see the denominators, like in sin square theta the denominator is 1 plus sin square theta, right? In LCM 1 plus sin square theta is already there. Along with that one factor is there, so you just multiply it with that factor, right? Now let's open up the brackets, and also I am applying the identity. See, this 1 plus 1 is 2, and cos square theta plus sin square theta is 1, and I am opening the brackets here. It will be cos square theta plus cos square theta sin square theta plus sin square theta plus sin square theta cos square theta, and denominator I am writing as such, which is 1 plus sin square theta, 1 plus cos square theta. This 2 plus 1 is 3, and cos square theta plus sin square theta is 1. So 2 plus 1, 3, plus this 1 of identity. It gives you 4. Plus sin square theta, cos square theta, here also it is there and here also it is there. So we can write it 2 sin square theta cos square theta upon 1 plus sin square theta. I am taking out 2 common from the numerator, which gives 2 plus sin square theta cos square theta upon 1 plus sin square theta. So here was one more term, 1 plus cos square theta, so I am just opening up that in the denominator. So 1 plus sin square theta when multiplied with 1 plus cos 1, it will be 1 plus cos square theta plus sin square theta when multiplied with both the terms will be sin square theta plus sin square theta cos square theta. So on opening up this is cos square theta plus sin square theta, which is 1, and this is also 1. So this 1 plus 1 is 2. 2 plus sine square theta cos square theta. These two cancels out and giving you 2, which is your RHS. This proves your solution. Moving to the next question now. Question number 7. It came in CBSE 2018 paper, and this is also the question from your NCERT. This is LHS, which is sin A minus 2 sin cube A upon 2 cos cube A minus cos. So clearly on observing the left hand side and right hand side, it's sure that if we get sin A upon cos A in the left hand side, only then we can prove it to be equals to tan A. And sin A is common from the numerator, which leaves 1 minus 2 sin square A. Same way cos A is common in denominator, which gives 2 cos square A minus 1. Now this is clear that this sin A upon cos A is tan A. So it means this whole part should be reduced to 1, so that only tan A can be the answer. So for that, what we can do, since in numerator it's sine and in denominator it's cos, so we are having the identity which relates both sine and cos. So either you convert the sine square into cos square, or you convert this cos square into sine square. So I am converting the sine square into cos square, as sine square A plus cos square A is 1. So sine square A can be written as 1 minus cos square A upon 2 cos square A minus 1. Opening up the brackets now, this is 1 minus 2 plus 2 cos square A upon 2 cos square A minus 1. So this is, the 1 minus 2 is minus 1 plus 2 cos square A upon 2 cos square A minus 1. Now see, these two terms are same, 2 cos square A, 2 cos square A minus 1 minus 1 cancels out, which is equals to tan A, and this is your RHS. This completes your question number 7. Come to question number 8 now. So question number 8 is if 4 tan theta equals to 3, then evaluate. In evaluate, you can see we have sin theta and cos theta. So with the help of this tan theta, first we will find the values of sin theta and cos theta, and those values we will be substituting here to get the answer. So this tan theta is what? It is 3 upon 4, and you know tan is perpendicular upon base. So with the help of Pythagoras theorem, we can find out hypotenuse from here, which will be 5. So what will be sin theta now? It's perpendicular upon hypotenuse, so it is 3 upon 5, and cos theta is base upon hypotenuse. Base is 4, hypotenuse is 5. Let's put the values now. It is 4 into sin theta, which is 3 by 5, minus cos theta 4 by 5 plus 1 upon 4 into sin theta, which is 3 upon 5 plus cos theta 4 upon 5 minus 1. So I am taking LCM as 5 in the numerator. So this is 4 into 3, 12, minus 4 plus 1 into 5, 5 upon again 5 LCM in the denominator. It's 12 plus 4 minus 5. This 5 cancels with this 5. This is 12 and 5 minus 4, 1. So 12 plus 1 is 13. And this is 12 plus 4, 16 minus 5, that is 11. So 13 upon 11 is the answer for this question. Moving to the next question, very important, question number 9. It's sin theta minus cos theta equal to 0. This is given, and you need to find this value, sin 4 theta plus cos 4 theta. So I am starting this question with finding the value of theta. Let's see the solution. We can write this as sin theta equals to cos theta. I am shifting this minus cos theta to the right side, which is 0 plus cos theta, cos theta. Now I am dividing this by cos theta. So it will be sin theta upon cos theta, and cos theta by cos theta is 1. So this is tan theta equals to 1. It means tan gives you value 1 at 45 degree. So 1 can be written as tan 45. So from here we are getting theta is 45 degree. Now to find this value, sine 4 theta plus cos 4 theta, I am using this 45 degree value. So this is fine. Sine 45 raised to the power 4 plus cos 45 raised to the power 4. Let's solve this now. Sine 45 is 1 by root 2. Cos 45 is also 1 by root 2. So 1 by root 2 raised to the power 4 will be 1 upon, see, root 2 into root 2 into root 2 into root 2. This is 2, this is 2. 2 into 2, 4. 4 plus 1 by 4. LCM is 4. 1 plus 1, 2. So answer is 1 upon 2. 1 upon 2 is the answer for this question. Let's move to the next question now. Question number 10. So you see the left hand side and right hand side in this question. In left side we have sine and cos, in right side we have secant and tan. So to get this left side in terms of secant and tan, I am dividing the numerator and denominator of LHS by cos A. See, so it will be sine A upon cos A minus cos A upon cos A plus 1 upon cos A upon, this is sine A upon cos A plus cos A upon cos A minus 1 upon cos A. So I have divided both numerator and denominator with cos to get the terms in these terms in terms of secant and tan. So now you see it is sine A upon cos A is tan A minus cos A and cos A cancels to give you 1, and this is 1 upon cos A, which is secant A. Same way, this is tan A plus 1 minus secant A. Now what we can do is, this can be written as tan A plus secant A minus 1 is there. Instead of 1 I am writing secant square A minus tan square A, because secant square A minus tan square A is also 1. This is tan A plus 1 minus secant A. Now I am applying identity here, A square minus B square. This is tan A plus secant A minus A plus B secant A plus tan A minus B secant A minus tan A upon tan A plus 1 minus secant A. Now I am taking out secant A plus tan A common from these two terms. Secant A plus tan A common gives 1 minus, I am opening the brackets also here. See, this is minus and minus secant A, and this is minus minus plus tan A upon tan A plus 1 tan A plus 1 minus secant A. See, these two factors are same now. Tan A, this is plus 1, this is also plus 1, this is minus secant A, this is minus A. It cancels out, and this is what? Secant A plus tan A. Moving to the next question now, question number 11. So this is x upon a cos theta plus y upon b sin theta 1, and x upon a sin theta minus y upon b cos theta also 1. We have to prove this thing, x square upon a square plus y square upon b square equals to 2. So clearly if we observe that in proving we need square of these terms, x square a square, और यहाँ जो हमें given है it is x upon a only, so obviously we are going to do squaring. Fine. So we'll start with squaring both the equations and then adding. On squaring 1 and 2 and then adding. So you observe, in left hand side I will add left hand side. It will be x upon a cos theta plus y upon b sin theta. इसका स्क्वायर किया और साथ में जो इक्वेशन नंबर 2 की लेफ्ट साइड है उसका भी स्क्वायर किया और उसको ऐड किया. दिस इज माइनस y upon b cos theta होल स्क्वायर और इस 1 का स्क्वायर किया तो वो 1 आ गया प्लस दिस 1 स्क्वायर इज ऑल्सो 1. नाउ आई एम अप्लाइंग a plus b होल स्क्वायर हेयर. It is x square upon a square cos square theta plus y square upon b square sin square theta plus 2ab is 2x upon a cos theta y upon b sin theta. Again applying here a minus b whole square. It is x square upon a square sin square theta minus y square upon b square cos square theta minus 2x upon a sin theta and y upon b cos theta, which is equals to 2. Observe this thing now. These two terms are same. This is plus 2, this is minus 2, so it cancels out. Now from these two terms I am taking out x square upon a square common. So we are left with cos square theta plus sin square theta, and from these two terms, sorry, this one and this one, I am taking out, it was plus y square upon b square common. This gives sin square theta plus cos square theta equals to 2. Now this is identity. Sin square theta plus cos square theta is 1. So this is x square upon a square plus y square b square equals to 2. So this proves your result. You can try these questions. First try the questions yourself by pausing the video, and then if you are not able to solve, you can see the solution. So thank you so much for watching the video.